Hi everyone, this is video 3 of chapter 5. It corresponds to section 5.3 in your textbook, and it's about connective tissue. As we get started, this section kind of feels like it's all over the place. There's a lot of information, and ironically enough, for something titled connective tissue, it can be hard to find the connections between bits of information. So I've tried to make the titles of the slides as clear as possible. I've tried to give you examples as much as possible. This might be a section that you need to spend a little bit of extra time on if it's new information to you. So in this video, we're going to talk about what all connective tissue types have in common. There are a wide variety of connective tissues, but they do have some things all in common. Then we're going to talk about the different cells that we find in connective tissue. Then we're going to talk about the matrix that holds connective tissue together and what that matrix is made of. And then we're going to classify several different types of connective tissue. And as we do that, we'll look at some pictures of connective tissue to see what they look like in human specimens. Okay, so starting off with kind of the big picture here, connective tissue is diverse, and that's part of what makes this section so challenging. We're talking about all of the connective tissue, which includes things like bones, but also blood and adipose or fat tissues. At first glance, it can seem like these things don't lump together into one category, but they really do. In connective tissue, the cells of the connective tissue generally take up less space than the matrix or the foundation that the cells are grounded in. Generally speaking, connective tissue support, connect, and protect the organs. Some connective tissue has lots of blood vessels, some has almost no blood vessels. So the vascularity is very different from one type of connective tissue to another. Okay, so like we said, there are very different types of connective tissue, so it makes sense that our functions are very different as well. Okay, so tendons and ligaments that are attached to the ends of your bones, they can connect those bones together and allow them to move or articulate. Some connective tissue, such as bone and cartilage, play a role in structural support. Your cranium, your ribs, and your sternum, they provide protection to your brain, your heart, and your lungs. We said a moment ago that blood cells are part of connective tissue, or classified as connective tissue. So your white blood cells are part of your immune system. Connective tissue has a role in movement. Think of your tendons and ligaments and bones. Their structure allows for movement. Portions of connective tissue can be used for storage. Your adipose or fat tissue is energy storage. Your bones are calcium and phosphorus storage. Connective tissue in the form of adipose tissue, specifically brown fat that we see in infants and young children, that is a big heat production mechanism. And finally, our blood transports oxygen. The red blood cells hold on to that oxygen and carry it around the body, exchanging it for carbon dioxide. So, diverse types of tissue have diverse functions. Okay, so now we're going to talk about the different types of cells that fibrous tissue can contain. Okay, so again, these are going to feel like they're all over the place, and really they are, because so many different things that are different from each other get classified as connective tissue. Okay, so the first thing we're going to talk about here is the fibroblasts. So fibroblasts are fibrous cells, and they're going to be found in that ground substance of the matrix. Then we have macrophages. So macrophages, we talked about phagocytosis in previous videos, where a cell engulfs and kind of eats another cell. Okay, so macrophages are professional phagocytes, and they are part of connective tissue. They have a role in the immune system. Okay, we talked about white blood cells being part of the immune system. Okay, so white blood cells, we also call those leukocytes. We have several different types of white blood cells. Neutrophils are one of the most important and one of the most abundant. We also have lymphocytes. Those are important as well and fall under the category of white blood cells or leukocytes. Plasma cells have the ability to synthesize antibodies. Mast cells are another cell that travel in the bloodstream, and they help in healing and also allergy responses. And then we have adipocytes, and adipocytes are the things that store triglycerides. They're fat molecules. They are your fat cells in your body. Okay, so now we're going to talk about the different fibers that make up connective tissue. Okay, so the first one and the most abundant one is collagen. Collagen makes up 25% of your body's protein. It's very tough, it's very flexible, but it does not want to stretch. So it can twist and turn, but it does not stretch well. And collagen makes up the tendons and the ligaments and some of the layers of your skin. Reticular fibers are collagen fibers that are coated with a glycoprotein. Remember that a glycoprotein is a carbohydrate protein complex. And reticular fibers, their biggest role is forming the framework that gives the spleen and the lymph nodes their shape. Okay, and then we have elastic fibers. Okay, elastic fibers are thinner, they tend to branch and then rejoin. They are made up of a different protein. They're made up of a protein called elastin, kind of an appropriate name there. And unlike collagen, elastin can stretch and then recoil back to its original length. All right, so now we're going to be talking about the ground substance that surrounds fibrous connective tissue. Okay, so this is a gelatin-like or gelatinous substance, has a rubbery consistency, and it has three main components. Okay, so the first one is glycosaminoglycans, and we call those GAGs or GAGs for short. Glycosaminoglycans. So these are long polysaccharides. Remember that a polysaccharide is a chain of monosaccharides or carbohydrates. These GAGs have a big role in keeping the electrolyte balance in different tissues. Chondroitin is one of the most important GAGs, and it's responsible for the stiffness of your cartilage. If you've ever looked in the supplement section at a grocery store or health food store, you might see glucosamine chondroitin. Chondroitin helps with joint health. It's something that we can take as a supplement to help our cartilage stay healthy. Then we have proteoglycans. Proteoglycans are a protein with GAGs attached to them, so it looks like a bottle brush. And this is kind of a weird description, but they form gravy-like colloids, and these are things that kind of hold tissues together. And then we have adhesive glycoproteins. These are another protein, carbohydrate molecule, and their job is to bind different tissues together. Okay, so now we're going to be looking at loose versus dense connective tissue. So we have two types of loose connective tissue. We have areolar, and areolar is pictured up here. Okay, so areolar is a type of loose connective tissue. It has more of that ground substance between the cells as compared to the dense connective tissue, so more ground substance and less cells. This areolar can take on several different appearances. It kind of is unorganized looking, and the cells are spread out compared to the tissue as a whole. Reticular form more of a mesh or a net-like structure, and we can see that here. This is reticular loose connective tissue, okay? When we compare these loose connective tissues to the dense connective tissues, that comparison gets pretty obvious for us. The loose connective tissues, the cells are further apart in that ground substance than in the dense connective tissue. We have two types of dense connective tissue. The first is regular, and regular, all the fibers are going to be going in the same direction. They're going to have this parallel form. Oftentimes they'll be wavy-like. And then irregular dense connective tissue is more dense than the areolar or reticular, but it's similar to those in that the fibers are going every which direction. There's not a lot of structure within the tissue itself. Okay, so now we're going to go through some of the individual types of connective tissue. We're starting with adipose tissue. Another word for adipose tissue is fat tissue. Adipocytes are fat cells, and they're the main type of cell in adipose tissue. So, in between individual adipocytes, we're going to find areolar tissue and reticular tissue, so that loose tissue. We know that fat is how the body primarily stores energy. So our fat cells are going to be filled with triglycerides, and the number of adipocytes doesn't really change in a person. The adipocytes themselves can get larger or smaller depending on how much fat is stored. So if a person gains weight and gains adipose or fat tissue, maybe around their belly, that's adipocytes getting bigger, not adipocytes dividing or becoming more in number. Likewise, if a person loses weight, the adipocytes get smaller. They don't go away. There aren't a fewer number of them. We do have two types of adipose tissue. In adults, we really only have white adipose tissue. Some people say it looks kind of like chicken wire in its structure. You can kind of see that in this picture here. We use it as cushioning, we use it as thermal insulation, and of course fat storage. Brown fat tissue is brown in color because it has more blood vessels and because it has enzymes that make it look brown. And this is heat generating tissue is what it's primarily used for, and we don't see it in adults. So next we're going to talk about cartilage. You guys are familiar with cartilage, especially in the top portion of your ear, in your nose. It's also in a lot of our joints, between cartilage in our spine, or between the vertebrae in our spine, we find cartilage. Chondroblasts are the cells that make cartilage, and they push them out into a matrix, and then that matrix traps them in place so they can't move. Once those cartilage cells are trapped and fixed in the matrix, they're called chondrocytes. Cartilage is interesting in that it doesn't have any blood vessels. So that means all of its nutrients and wastes are brought and removed by diffusion. It also means that cartilage heals very, very slowly after it's injured. We have three types of cartilage: hyaline, fibro, and elastic, and we're going to talk about each one of those separately next. So hyaline cartilage is clear, glassy in appearance. This is what helps your joints move, holds your airway open, your trachea, allows your vocal cords to move. We also find this in the fetal skeleton. It has that clear, glassy appearance because the collagen fibers in it are very, very fine. elastic cartilage gets its name from a high amount of elastic fibers that are present in it. It is more flexible and it allows things to kind of stretch and then recoil back into place. So the outside of your ear is made of this type. And fibrocartilage is the type of cartilage that has the largest and coarsest and most dense amounts of collagen. It does not like to be compressed, so it's a shock absorber. Okay, so we see this especially in the discs between vertebra in the back. So our next connective tissue is bone. So everybody is familiar with bone and at least a little bit about the skeletal system. Okay, so osteocytes are the name that we call mature bone cells, and we have two types. We have spongy bone, which is porous in appearance, and then we have compact bone, which is more dense and doesn't have any space between those osteocytes. We see compact bone here. We have blood vessels and nerves that go through a central canal, and then onion-like layers around the central canal. Kind of interesting right here. You can see those onion-like layers. And the final connective tissue that we'll talk about is blood. And blood is a connective tissue. It's fluid, obviously, in humans. It's involved in transporting things. It also includes the white blood cells, which are part of the immune system, and platelets, which are actually cell fragments that are involved in clotting. The ground substance of blood, remember that this connective tissue has the cells, in this case red blood cells, white blood cells, and platelets. Those have to be in some sort of ground substance. The blood's ground substance is the plasma.